What if you could take a top-tier AI model, sever the connection to the internet, and run it locally without paying any subscription fees? Google recently released Gemma 4. It's an open-source AI model built from the same research as their flagship Gemini system, and it is designed specifically to operate locally on your personal devices. Standard cloud models cost around $20 a month and enforce strict usage caps. Because Gemma 4 lives entirely on your hard drive, there are zero recurring costs, and you will never hit a rate limit. You can prompt it continuously all day long. Running an AI locally means your data never leaves your machine. You transition from renting access on someone else's server to owning the software doing the processing. Step 1 is figuring out which version of the model to download. Because local AI utilizes your physical hardware, you have to match the model size to your computer's available RAM and GPU. If you pull a model that is too large, your system will crash. We break down 4 hardware tiers. Tiny E2B models fit phones. The 26 billion parameter tier is your sweet spot for 16 to 24 gigabyte machines. To run this, open your terminal and type Llama pull Gemma 4 26B. Now that the download is complete, physically turn off your computer's Wi-Fi. We are going to test this setup while entirely offline. Open a new terminal chat, type hello, and press enter. You will see the model process the text and generate a complete response instantly, despite having zero network connection. Successfully executing this offline prompt proves your workspace is entirely self-contained. The processing speed is now determined solely by your computer's chip, eliminating any lag caused by server traffic. Step 2 is upgrading from simple text generation to automated workflows. We do this by plugging the local Gemma 4 model into an autonomous coding framework like OpenCode. A standard chatbot waits for your exact instructions for every single action. An agentic framework takes a single goal, breaks it into multiple steps, and executes them consecutively on its own. To bridge these two tools, go back to your terminal and enter the command Llama launch OpenCode. This binds your downloaded Gemma 4 model directly to the autonomous framework. This flowchart visualizes the agent's permissions. Because everything runs on your machine, OpenCode is authorized to read your Active Directories and write new code files directly to your hard drive, all inside a secure local boundary. Granting the AI local file access moves the workflow from passive advice to direct execution. The agent generates the necessary code and then automatically instantiates the file on your hard drive. Let's test this agent with 2 distinct tasks: building a single-page HTML landing page for dog supplements and coding an interactive double pendulum physics simulation. This chart compares generation timelines. A paid cloud server completes the HTML task in under a minute. Our local Gemma 4 setup processes a bit slower, taking roughly 2.5 minutes to write the complete file. Despite the slower generation time, the local model successfully output the physics simulation. Opening the generated file reveals a fully functional double pendulum running smoothly right inside an offline web browser. Generating this locally solves a major enterprise problem. You never have to upload your proprietary codebase to an external server. The intellectual property stays entirely on the host machine. This same boundary applies to documents. You can point the agent toward a sensitive, locally stored PDF, and it will analyze the text and generate a summary without ever pinging an external network. By utilizing your own hardware, you trade a fraction of raw reasoning speed for absolute data privacy and zero recurring subscription fees. Step 3 brings this ecosystem to your pocket. Open your App Store and download the Google AI Edge Gallery. From there, install the highly compressed E4B mobile model. To verify the isolation, manually switch your smartphone into airplane mode, disabling both cellular data and Wi-Fi connections entirely. The mobile version retains its multimodal functions. You can snap a photo of a document or an object, and the phone's native processor will extract the text or identify the subject using only the downloaded model. Running this model directly on a smartphone chip eliminates the need for cell towers or Wi-Fi. You can analyze data, instantly translate foreign text, and draft emails from anywhere on the planet. We have now constructed a localized autonomous coding agent on the desktop and a multi-modal assistant on the smartphone, functioning seamlessly in complete isolation. To refine this setup, you can adjust the system prompts in the OpenCode framework. Did it highly detailed instructions on your specific formatting preferences so the output consistently matches your own personal coding style? Once you have your local environment running, drop down to the comments and let us know what your very first offline generation was, and make sure to subscribe for future tool setups. Owning your models and data establishes a permanent, private workspace that functions regardless of subscription status or network stability.